Hello, welcome to the video. Uh, this section, we're going to be looking at 6.5. We're going to focus on properties of logarithms. So it says, how can you use properties of logarithms to derive, I'm sorry, how can you use properties of exponents to derive properties of logarithms? So what we are going to do is we are actually going to be looking at um, two different things when it comes to logarithms. All right. So the first thing that we're going to look at is being able to expand a logarithm. All right, so we're going to be looking at two focus on two terms. So we're going to be looking at expanding a logarithm, and we'll also be able to looking at condensing a logarithm. And through these properties, we will be able to look at both and it eventually through different examples, we'll be able to solve these logarithmic log logarithmic equations um, with some given information. So before we get started on any of the examples, we are going to take a look at how we can first expand. So this is going to show us how we can expand a logarithm. So if you look at the logarithms that I underlined, those are all logarithms that are in condensed form. Okay, you know, they're more compact. There's less logs, in each expression, and the expressions here that I'm circling are examples of logarithms that are expanded. Okay, um, when you expand some logarithms, there'll be more than that, um, just because of whatever given information you may have. You may use multiple properties to assist you in expanding a logarithm. But the first one here is the product property. So if you have inside the log two numbers or two terms that are being multiplied, to expand it, you can kind of break them apart and add the two logs together. So log base b of m times n is the same thing as log base b of m plus log base b of n. The quotient property states that if you have a log base b and you have a fraction or a division problem, m divided by n, you can subtract the two values of m and n and make them as their two separate logs. So you could say that it would be log base b of m minus log base b of n. The final property is dealing with exponents. So what you can do is you can say, oh, I have this log base b of m raised to the n power. What you can then do is move whatever that value is that is being raised to whatever power, can you move to the outside and say that it is n times it by whatever the log base b of m actually is. So how does this help us? Well, in examples such as these, they are giving us um, certain relative values of certain logs. So they're saying that log base 2 of 3 is about 1.585 and log base 2 of 7 is about 2.807. So with that information, they want us to evaluate each of these logarithms. So what we have in example A, we have log base 2 of 3 over 7. All right. Right now, I can't solve that But what we can do is, oh, well, 3/7 is a fraction, which is a quotient. What then I can do is I can expand this logarithm by saying, oh, this is the log base 2 of 3 minus the log base 2 of 7. Well, what they told us, oh, we have a value for both of those. Log base 2 of 3 is 1.585 minus, oh, log base 2 of 7 is 2.807. Subtract these two and I get a negative 1.222. And that is my evaluated logarithm. If I look at B, I have log base 2 of 21. Again, I can't do anything else with that, but I also know that I could rewrite 21 as 3 times 7, because 3 times 7 is 21. That is going to help us because now I can expand the logarithm and say, oh, this is log base 2 of 3 plus log base 2 of 7, and I have values for those. So this is 1.585 plus 2.807. Add those together, I get 4.392. I look at my final example, and it is log base 2 of 49. So, get an idea, well, 49 is not going to help us. I need something with 7. So I'm going to say, like, well, another way of writing 49 is 7 squared. Well, now I can use that power property, and now I can say that this is 2 times it by log base 2 of 7. Well, I know that log base 2 of 7 is 2.807. Now I just multiply 2 by 2.807, which I get something like 5.614. All right, and questions 1 through 4 are very similar to what we did in the previous page. If you want to, leave me a comment. I'm more than happy to work these problems out. Okay, so now what we're going to look at is they're asking us to expand this logarithm, all right? More specifically, they're asking us to expand the natural log of 5x to the 7th divided by y. So what you have to think about when they ask you to expand, they don't want any multiplication, division, or exponents inside the log or the natural log in this particular instance. So we have to use all those properties to utilize, whatever it is. So in this case here, because we have a fraction of 5x to the 7th over y, the first step you're going to do is you're going to use that quotient property. So now we're going to say that this is the natural log of 5x to the 7th minus the natural log of y. Now what you're going to do is make sure that there are no multiplication, division, or exponents inside these logs. So y is by itself, I'm done with that one. So natural log of y stays the same. This here, I have multiplication and I also have an exponent, all right? The exponent is only attached to the x, so I don't do that quite yet, but I can uh, use that product property to help me expand the 5x to the 7th. So now this will turn into the natural log of 5 plus the natural log of x to the 7th, and I still have the minus natural log of y. Natural log of 5, I'm good. Natural log of 7 to the x, well, I have an exponent, so now I have to use that um, power property. So the final step is going to be the natural log of 5 plus now it's going to be 7 natural log of x minus natural log of y. All right, 5xy, there's nothing left inside. That's multiplication, division, or exponents. This is my expanded logarithm. Here they want us to condense it, all right? So that means we have to kind of look at all of the different properties in reverse. So looking at this, so now it's log of 9 plus 3 log of 2 minus log of 3. So just like how we did the expanding, we we ended with exponents. Now we're going to start with exponents. So looking at this 3 on the outside, that means that is part of an exponent. So to help condense it, I get log of 9 plus, now it's going to be log of 2 raised to the third power minus log of 3. Okay. Now we take care of, remember we started with division in the first problem with expanding. Now we're going to look at multiplication first when we condense it. So now this is going to be the log of 9 times 2 to the third minus log of 3. To finish up the properties, I have a minus, which means it's division. So now I have log of 9 times 2 to the third divided by 3. Okay, but this particular example, they're all numbers. So let's evaluate and simplify. So here, this is going to be log of, so 2 to the third is 8. 8 times 8 times 9 is what, 72? 72 divided by 3 is 24. So this comes out to, as a condensed value, the log of 24. All right. Another um, another thing, another formula that I find incredibly helpful when it comes to solving logarithmic functions is using the change of base formula. All right, so the change of base formula says that if I have a log base c of a, you can rewrite this as the log base b of a divided by the log base b of c, making b whatever base you want. All right, and our calculator since our calculator does everything in base 10, my suggestion to you is always make b equal to 10. So then we can plug it into our calculator that way. So here it says I want to evaluate log base 3 of 8. It says using common law. I just say let's use the change of base formula. Use the change of base formula. So I want to rewrite this using the change of base formula. So it's going to be the log of 8 divided by the log of 3, okay? Again, making my base as 10. So what you can now do is go to your calculator and say, oh, this is log of 8, parentheses divided by log of 3, and then I hit enter, and it is about 1.893. Okay, so it is about 1.893. Again, same idea. You have this one here. So I want to rewrite this as this one's going to be log base, or no, I'm sorry, just log of 24 because I want it to be a base of 10, and it's going to be log of 6. So again, I can just type in log of 24 divided by log of 6. And I should get a result roughly 1.774. And that is being able to look at properties of logarithms. Hope this helps. Until next time.